All right. So sorry I couldn't make it to class or to the demonstration. I'm going to record a video and hopefully you guys receive it well. Um, so apologize for that. I was out of pocket today, but this is going to be for my computer science 688. I did a collaborative project with Attila Varga. We were working on a project called Internet of Things for Legacy and Project Cars, and I'll get into more of the project later. This is what we're going to go through with the agenda. We're going to go through the problem statements, problem solution, functional requirements, the project plan, roles and responsibilities, feasibilities, analysis of alternatives, risks, project management, development environment, software tools we used, integration, and demonstration. This is a sum up or roll up of the 3 months that we had in class, where we first started initially with the requirements phase and the design phase and then the implementation phase. So this kind of encapsulates all the different phases of the software development cycle. So what I'd like to do is start you off with the problem statement that we had in mind for our project. And the way we approach this is we wanted to add value to customers for customers that have old cars. And when you look at new cars today that are coming down the line, the new cars, they have sensors, they have integrated with the internet. It's very high tech. And so somebody that has an older car and they want to be able to, have connected sensors to the internet and to the cloud, we want to be able to provide that for them. We want to be able to enable them to have a heads-up display so that they don't just rely on analog gauges. Be able to have that information available for them in some sort of data format so that they can assess what issues they might have or how they can perform better or, things like that. And so having a connected car with the Internet of Things will enable that. And so that's our solution. We want to develop a user-friendly sensor heads-up display that would be able to integrate with legacy and old cars and provide real-time data on the car's fuel consumption and RPM, along other metrics, but we focused on fuel consumption and RPM in this case. We'll provide them with a digital dashboard of sorts so that they can see what they would normally see in their gauges. And then we'll connect to that with their phone and a mobile device, and then they'll be able to update that into the cloud. So that's our solution that we aim for, and fill the gap and fill the need for really for people that have older vehicles and they want to be able to connect to them. Sensors. Okay. We'll go through our functional requirements. And here in our functional requirements, we'll talk about, okay, yeah, we have real-time, low latency time data. So what does that mean? We want to be able to get data from the vehicle real time or near real time. And so that'll be transmitted over the air into our phone, into our app. And we're getting RPM data and fuel injector data. We're also wanting to scale this so that we can add more sensors. So we added that feature as well, so that we can add more sensors to the vehicle. And we want to be able to connect this to the cloud and perform offline operations. So what this requirement is talks about we want to be able to connect to the cloud and add the database on the internet. But we want to be able to, without internet access, we still want to be able to process our fuel data and RPM data and other sensors. So that's what that requirement is. We were going to use this as an Android app. So all the UI and everything, all the data processing was done for an Android. And the communications technology that we're using is we're going to be using Bluetooth technology. And the database that we'll be using is a SQLite database, as well as the online Firebase database. Okay. For non-functional requirements, we are trying to have a customizable experience for the user. And so that was, I want to say, a stretch goal for us to have a customizable application. And security, really, we didn't process any sensitive data, any sensitive user data. So security was kind of not very, like, what's the word I'm trying to find? It wasn't relevant for our project, if you will. But we will provide patches and have continuous bug fixes as part of app maintainability, and we'll have a user feedback mechanism to do that. So non-functional requirements were more stretch goals, and we focus solely on the functional requirements for this project. For the project plan, we did create a plan of action and milestones so that we can stay on track and we can stay on schedule for our project. But this was the high level of what we were going to do. We're going to develop, design, and agree on the agile development process so that we can provide incremental builds and demos as we develop our software. We needed to choose a good platform that we were going to test this on. And so we chose, Attila can talk more about what we chose and on the sensors. And then we deployed two main sensors. We're going to do the fuel sensor and the RPM sensors, the two main sensors that we're going to be using. And we're using the Bluetooth connection on the Arduino side to send that data over to a phone that already has a Bluetooth capability and connected to it. So the phone that we're using is a Pixel 7. And so it has a Bluetooth API on that mobile phone. And then we'll develop the user interface on the phone so that the user can navigate through the different windows, update their data, connect to the devices, view their dashboards and things like that. And then, yeah, we'll connect that to the cloud, and that way they can see that over there. Okay, the way we broke up the project responsibilities is Attila was focused on the embedded side and I was focused on the application side. And I'll just touch on what I did. I developed the Android application user interface. I created different services within that interface. One service is a database, SQLite service, Bluetooth service, as well as the Firebase cloud connectivity services. So that was all developed within there. And then I translated that data for visualizations on the heads-up display. And so as part of the development process, we started off with the design phase where we had the user interface design. We'll talk about that later. We had a development phase, a test phase, and then we optimized it and iterated on it so that we can improve upon our development cycle and have a good first iteration prototype. And you'll see that in the demo here shortly. I will leave the feasibility analysis for Attila. I think he can talk through the technical and the schedule. I updated the schedule here. So we did complete the design May 30th, and we had some development time between the 8th and the 17th of July. And then we started integrating here this month. So the 17th through the 21st was really the integration and test phase. And then we had this week, the 21st to the 26th, to fix any bugs. I'm getting ready for today for the demo day. So yeah, that's our schedule and feasibility analysis for that. And we'll talk about that. In terms of analysis of alternatives, so we did have some options to choose from as we were doing our feasibilities and as we were doing our project plan. We did consider doing iOS. We chose Android for other reasons, mainly because the development was being done by myself on the Android app. And so I had the Android, I had a Pixel 7, so that's why I chose Android. We did have different options. We could use Wi-Fi, we could use 5G or Zigbee or other protocols. We chose Bluetooth only because it was a accessible, quick prototype that we could use on both Android and also on the Arduino. We could use different sensors, but we chose the ones that we thought were the most relevant ones on the fuel and the RPM, but we could have choose speed or add cameras or added some alarm sensors or some other stuff to the to the car. And that's all part of the scalability. And then in terms of cloud, we did use the Firebase cloud. We could have done Amazon Web Services, MongoDB, among others. Okay. And then in terms of the risks, I'll touch on risks 4 and 5. We did assessed that there was a risk in terms of supply chain issues, especially with the, with some of the chip things going on, and having scarce resource with chip availability. So that could affect us, especially as we start to scale and produce more of these devices and these sensors. But in terms of also on the app side, there was a risk on the app side, and that's if it's not connected to the internet, then there is no internet connectivity to back up your data to the cloud and be able to restore data from the cloud. But then again, this risk is mitigated by being able to process the data and the sensors offline and store it on target on the phone on a SQLite database server, which has been implemented. Okay. So for project management, as we started the execution of the project, we did choose the agile development approach. We had sprints and iterations, and we did do incremental demonstrations provided in class. So that was a good approach for us to take. We decided this over waterfall approach only because we had an idea of what the requirements were up front, but we didn't do a full systems modeling or systems engineering approach up front to be able to fully define the requirements. Instead, we took an iterative approach and developed capability on both the app and on the sensor side iteratively, and provided demonstrations for those. We did use the online tools to be able to do some project management as well. So we chose Atlassian for documentation and issue management, specifically Jira database, so that we can track our bugs, track our tasks there. And then we also use GitHub for our source code management and version control of our software development. In terms of our development environment, for the sensor side, we used the Arduino IDE, where we had access to the serial terminal for debugging, the Bluetooth API for transmitting the communications over the air, and then calibration data so that we can calibrate the RPMs and the fuel over to the Arduino and send that over there. We had also used Android Studio for our Android development. And I talked about this already. We created Bluetooth services where we can find devices, paired devices. We can store those devices in a database and recall those paired devices. And then we can connect to those devices. So that's what all the Bluetooth service does. And then the SQL database services creates different tables for the user. And I'll go through the actual database in a second, but it creates tables for the user, for the vehicle, for the sensors, the sensor controllers, and we can associate those together and have our data accessible for the user. And then the online database was a Firebase database where we used, this was a NoSQL database, but we have a JSON file interpreter that will upload that to the Firebase. Okay, that to database. These were the software tools and the links for our project for Jira, GitLab, and Firebase. Some of the integration challenges that we experienced were we were working independently. So I was working on my side on the mobile app, and Attila was working on his side with the Arduino development. And so we didn't really interact much in terms of meeting up until the integration period, which was last week. And so that made it challenging to bring our codes together, but we were able to find some bugs, some problem reports, be able to fix them right there during our integration period and patch those software fixes into our code. So once we did that, we were good to go. We also needed to agree upon our communication protocol and data structure of what we were sending and receiving. So as Attila receives his sensor data and packs it in to his transmit side, I need to unpack it just the way he packed it in. And so we needed to come up with some protocol for what that was going to be. We agreed on that, and we were able to successfully send data over the channel. But that was good. I think Attila is going to talk through the use cases here on the RPM, the fuel eco settings, and other things, and customizations, things like that. And I think he's going to talk about the data flow diagrams as well. You know, how we're sending data from the vehicle all the way to the end user. And here's the user interface design. So we wanted an interface design that would be simple for the user to navigate the different windows. We wanted to show the gauges so that we can have a digital dashboard of the analog sensors that the user has connected in his old vehicle. So we use the RPM and the fuel efficiency sensors, and we have dashboards for those. We also wanted a dashboard so that the user can connect to the device. They can see their paired devices. They can see any new devices that are around in the area that can be ready to pair or connect to. So we want to be able to connect to those devices. And so we had a user interface designed for that. And we needed a place also to put in their user information, their contact info, as well as any vehicles that they're going to be connecting sensors with as part of their app. So we needed that information as well. So that was part of the user interface. And then this is how we tied the different data assets together, the data database, if you will. So we have one user to one mobile app where the user can store their phone and email, for example, sends that back. We can store a vehicle data table where we have the year, make, model, ID, and with calibration data, and that can connect to many sensors. So one vehicle can have many sensors. And the sensors has a sensor controller with sensor type. And so sensor controller in this case would be like the Arduino. We can have many Arduinos within this database, but each Arduino can also have many sensors. So then we can tie a sensor controller with a sensor ID, and the sensor type. The sensor will have a sensor type and a sensor data source that it can send to the sensor controller, and then that sends that over to the controller, to the mobile application, and we'll process that data within the app and display that in our different user interfaces. So this is kind of a high level. And then so the feedback that we've got was we are storing this in the cloud. So this is a database, and the cloud is just being used for backup and restore. So whatever this you see here is what you'll see in the cloud. Okay. So give me 1 second. I think I might have done something here. So I just want to talk about the demo, what you're going to see. So sorry about this. Give me 1 second. This is how it's supposed to be. So, okay. So now we're going to talk about test and evaluation. So test and evaluation, we wanted to verify after we've integrated our system into our car, and we had the mobile app and everything was working. You know, how do we verify that everything was worked? Well, we got to go back to our requirements. We have requirements traceability, and we checked each one of those requirements were valid, were validated. And so we checked that, yep, it was a real-time low latency. We can see real-time data over there. That's good. Scalable sensor integration. Yep, we see that between fuel sensor and RPM sensor, we have different sensor IDs. And when those IDs can be scaled up, so that we can do different sensors. We can also connect that to the cloud and have offline operations. So you'll see that as well. So that's a check. It is in Android. You'll see the mobile app. So that's a check. We are using Bluetooth data. So you'll see that as well. And that's a check. And then we are storing that in a database. So that's a check. And then, yeah, we are definitely fixing bugs even now as leading up to the demo. So we are definitely checking that app maintainability. And so the ones that we didn't do are the non-functional requirements. And I put those as orange only because they're something that we are planning to incorporate if we continue this project. But security and customization is something that we were looking at including as well. All right. So here we go. So this is going to be the system demo. We're going to show you two different videos or two different types of demos. One of them is going to be from my side. on the application side on what it does. And then the other side is going to be on the Attila side with the vehicle and the sensor integrated and everything working on his end. So that's what you're going to see. So the windows that I'm going to show you here is, so you'll see a window here in the middle. This is the mobile app. It's actually already connected. I have it running here on my phone. So this is a mirrored image on the computer. You'll see that. You'll also see the real-time database, which is the online database that is storing the data. And so you'll see that here. You'll see this window here is the Logcat for Android, and it's just showing demo traces. And reason I'm showing this is so that you can see that the data is being stored in the database here as well as here. And so you'll see some traces here, and you'll see some traces here. And then this, you'll see the, I'll show you another video that I recorded where it shows the acceleration going up and down, and you'll see the traces being done with that. Okay, so a couple different things that we're going to show you, and we'll get to that demo right now. So I'm going to hop on over here. Okay, so here we go. So now I'm going to show you the navigation for the user interface. So the first thing you're going to see is we're logged in. This is the main page. And then from here, we can update our user information. Okay. And so we can scroll up and down and update anything that we want. So we have a Mr. George with phone number that, and we'll update that. And you'll see that update, add a new user, right? Mr. George with phone number and stuff like that. Okay, so that's good. Then we can also add and remove vehicles. So if we wanted to make a 2014 Toyota, for example, Tacoma, and we can add that vehicle, and then that vehicle is added, and then you'll see here in the local database. So, and then that's here, 2014 Toyota Tacoma. So we can add our data into our databases on both locally and also in the cloud. So that's good. That's what we wanted. Check. By the way, we're checking our requirements here. Check. Okay, so now can we connect to the devices? So first thing is we can see what devices we have paired. Okay, so those are there. And you'll see them here, devices paired. And then we'll also can find new devices. So if we go and we click on that, we'll finding new devices. This is actually going to take a second, so just bear with me while this is finding new devices on Bluetooth, and then you'll see that populate. There it is. Those are devices. In my case, I'm already connected to my device, so I'm just going to go back, and then we can go to view RPM. So now we saw user info where we can add user, we can add the vehicle, we can connect to the devices, find new devices or find existing devices. And now we have our two dashboards, right? We have the view RPM and view fuel. So now we're going to go and show you view RPM. And so here in view RPM, we're going to start this. And so right now you'll see a RPM of 800, for example. And as we start collecting RPM data, it's going to log it. And then as soon as it exceeds some threshold, it's going to alert the database. Hey, you logged the threshold. And so we're going to go increase RPMs and then decrease them. And then you see it logged a threshold, right? So now we can, whenever we exceed some sort of thresholds that the user sets, we can log those as well. And so the user can then go back and assess the data for their vehicle as they were driving it normally, right? And they can kind of say, oh, look, I drove fast. All right, so that's that one. And now we have the view fuel, same thing here. So now we're starting to collect fuel data. And as we accelerate, oh, there we go. Now we can see that it's stored and it triggered an alert. Okay. So yeah, these are two different views for show RPM and view field and connect devices and user info. So now let me show you the video with the car, and I think Attila might have that as well. So I think that's it. Let me see. Yeah, I think that's it. All right. Well, thank you so much for your time.